Set? Thank you, Brian.
Good morning, everybody. I thought I was going to have to wake you all up, but Francis has just done an amazing job at that. So thanks for getting everybody going here. So I'm here wearing two hats today. I'm the Chief Technology Officer at Intrinsic, which is we're a subsidiary of Alphabet. So you can think of us as a very, very, very small brother to Google. Also Waymo, Verily, Wing, if you're familiar with those companies. Where we're making robot software that is facilitating programming and reprogramming robots, mainly for manufacturing. But I also wear another hat. I'm the founder and board chair of a nonprofit called Open Robotics, where we push for the development and adoption of open source software in robotics. And so I'll wear that latter hat today and really talk about, make an argument to you for the importance of openness in the underlying platforms that we use as we roll out embodied AI. So, just about me, I'm a roboticist. I'm a computer scientist by training. I'm basically a software engineer. And to me, embodied AI means a system that has a physical body and it's tantamount to a robot. So I read the topic of this conference is embodied AI. I just substitute robot in there. That's what I do. Now, I like robots a lot. Really, of all the different technologies I could work on, I find writing code that makes robots move around in the world to be just the most compelling thing I can do. And I come at it as a technologist, even absent any particular purpose for the robot. I just find them the most compelling things to work on. I've also been at this for a long time. That's the first robot that I worked on, the RWI B14, which was one of a class of so-called trash can robots that were popular in the mid-90s because it is kind of shaped like a trash can. Those little rings around the top are ultrasonic sensors. This is long before LiDAR became affordable. We used these sonar sensors that were actually made by Polaroid because they took them out of the old Polaroid cameras. That's how the Polaroid used to autofocus, was with this ultrasonic sensor. So let's see. Are robots actually useful? So I love robots. I also think most of them are not that useful. Now, one that I think probably is pretty useful is floor cleaners. Since the Roomba was introduced in 2002, there have been somewhere between 1 and 200 million floor cleaners sold in the world. Many of you probably have at least one. I know we have two, not Roombas, but we have two floor cleaners in our house. So I'd say that's pretty useful. Now, I was torn about this because I wanted to show a robot that I would argue is not useful, and I didn't know if it'd be controversial, but I think Jordan kind of let me in on this yesterday when he argued that SoftBank is turned away from Pepper and said that it was actually a good thing, and I would agree, because I think Pepper's a good example of coming at it from a technology push perspective, having a very strong prior over just it's kind of what I would do if you asked me to design a product. I would say, well, I think robots are cool. Let's make a robot like this, and I bet we'll find something useful to do with it. But I think, as Jordan admitted yesterday, that didn't really work out. That robot was intended to do a bunch of service applications, but the arms and the hands don't actually do anything useful. I got yelled at in Japanese in the Narita airport one time, arguing that I should come in and use their currency exchange services, but that's about the only time I've ever interacted with one of these. So how do we fix this? I think that what we need is more ideas. What we want to do is bring more ideas for what robots can do into the ecosystem. And I think as a roboticist, I think I'm uniquely poorly positioned to come up with what should a robot do. So what we want to do is bring more people in who can bring those ideas for what the robot should do. So I'm good at building the technology that lets you program the robot, but I'm not the right person to tell you what the robot should do. So what we want to do is make the field more accessible to people so that they can come in and bring their ideas for what the robot is actually going to do, and then have a reasonable path forward to build and deploy that application without having to build everything from scratch. We want to make it possible for people who are not roboticists to be able to program robots. So how do we do that? First of all, I want to say that this is me when I was 12 years old, and I had the opportunity to go to space camp in Huntsville, Alabama. And I really always loved space. I was enamored of space. I grew up in the 80s in the heyday of the shuttle program. I had the pleasure to talk to Charlie Bolden last night, where I learned that not only was he the NASA administrator, he was also an astronaut and shuttle commander, which is pretty cool. He actually put the Hubble into space, as Juan explained to me last night. So that was a real joy. I always wanted to go to space. I haven't been, at least not yet, but about 30 years after I went to space camp, NASA put these robots on the space station. These are called astrobees. These are free-flying robots. They're cubes with fans on each side, and they can blow those fans in order to fly around inside the microgravity of the space station. They have sensors on them. They keep track of where they are, and they're helping the astronauts do kind of maintenance activities on the space station. Importantly, those robots run software that I and my team wrote. But even more importantly, we didn't build those robots, and we didn't help NASA put those robots into space. What we did is we built tools that then they were able to take and build their own application on top of. I had no idea what would be useful as a robot in the space station. NASA did, and because we provided this open platform, they were able to realize their need of having this robot that could help astronauts in the space station. So, how did we do that? Well, we focused on building tools. So if I can roll back a little bit further in the early 90s when I was in grad school, we had robots like this in our lab. They're mobile robots. This is an early version of a LiDAR, which is actually taken from an industrial system. And we wanted to program the robot. We were there to do science. So we're there to develop algorithms, do experiments. And so this is our experimental tool, basically, this robot. But we needed to be able to program it. And in order to do that, we had to write some code. So and this is what every lab did at the time. You wrote some code to program your robot. So we wrote some code to program our robot. But we went one step further, and we gave it names. Player was the interface, stage was the simulator, and we shared this code online under an open source license. So we distributed it to the world just because we thought, well, maybe somebody else will find it useful. And then before long, there was somebody in another group who was using the same software to program a pretty different robot. Not a wildly different robot, but a pretty different robot. It was a different physical embodiment. It had a different sensor suite. It was used for a different purpose. And that's when it hit for me that if we can build these tools in a way that has the right kind of abstractions and is easily enough reusable, as well as be willing to share it in an open way, then we can really have a very broad impact. Now, along the way, I've developed kind of a structure for how we think about these open platforms. So first of all, we're helping you to break down an engineering problem into pieces. And so to do that, we have to give you some plumbing. We give you some pieces some components that allow you to connect your system, to decompose the problem, to connect the pieces that you've put together. And that's what I think of as the plumbing. Also, programming robots is really hard. It has all the same problems of any other sort of software engineering task, but also you're dealing with the uncertainties of the physical world. You're dealing with a lot of sensor data. So you need good tools to be able to describe the system, to launch it, to introspect it, to visualize the data, to debug it. And so we spend a lot of time working on development tools. Now also, what we want to do is give you, as someone coming in from the outside with an idea for what a robot application is, we want to give you a bunch of capabilities. We want to give you the building blocks so that you don't need to build those yourself. So if as a community, we already know how to have a mobile robot run around this room and make a map and keep track of where it is, we should take that as given. That's sort of table stakes, and that should just come with the system. But then importantly, we also need an ecosystem. We need a community of people who are using and depending on and contributing to this system. So we're here to talk about AI. I'm going to actually just skip this and say that these characteristics are common across many different kinds of platforms, and the one I'll talk about today is really ROS, which is the robot operating system. But I also want to say, how do we bring AI into this? Where does that actually fit? So it fits in two places. One is at the tools level. So if you think about where AI is very, very commonly used today in engineering tasks, it's in the assistant mode, right? You think about these are your co-pilots, these are your design assistants. These are the systems that you can pose a problem and you can get a first draft of a solution. Now, very importantly, there's still a human in the loop in the application of those systems. And that means that the barrier, the sort of performance bar is actually a lot lower for those systems. It doesn't have to be perfect. What it can do is give you, if it gets it right 80% of the time, that's totally fine because you've still got a human in the loop who's saying, okay, you've given me that first draft. I'm going to tweak it, I'm going to change it, I'm going to correct all the hallucinations that you had. That's totally fine. Now, the higher bar is when we put the AI into the runtime. So now this is where we're giving, and this is happening today. What we're doing is putting into that sort of library of capabilities that come with the platform, AI-powered algorithms. And now, if that's going to be in the loop actually controlling the robot where you've taken the human out, now you've got a much higher bar for performance. You need to be very sure that it's going to do the right thing. Now, how did this all come to be? How did we get to develop this open platform that's now widely used? Jordan mentioned the Willow Garage Mafia yesterday. I guess I'm part of the Willow Garage Mafia. This was an unusual company that started in 2007 with the goal of revolutionizing robotics. Our plan was to, the premise of the company was to make it possible for more people to get into robotics, and to do that by building and sharing open systems. Now, we also had fun along the way, like the time we chartered the Zero-G plane and just went for a flight, because that was really cool. This guy here is Scott Hassan. He's the one who founded and funded Willow Garage. He paid for it just privately. And he was able to do that because he had been there at the beginning of Google, helping Larry Page and Sergey Brin write the software that became Google when they were still at Stanford. His motivation to start Willow Garage came from that experience, because his view was that when they came along and realized what they wanted to do with the internet, which was to build Google, they had an existing open source stack of software available. They were able to use Linux and Apache and MySQL and Python as just off-the-shelf tools, and then they could bring their need in terms of the application to the table. They could take all those pieces and put them together reasonably efficiently. He wanted to do the same thing for robotics. And so that was the premise, is that we would come together there and try to accelerate the pace of progress in robotics and make that sort of technology available to the next generation. So how did we do that? Well, we started out by building a robot, because at the time, it was actually pretty hard to develop. There weren't that many good robots available, and it was very, very expensive to build your own robot. That has actually changed in the last 15 years. It's become much easier to build a robot from commodity parts, and so I wouldn't do this today, but 15 years ago, I think this was the right move. So we built the PR2, which is a robot that you see here. It's mobile, it's got arms, it's got a sensor head, and it's meant as a research tool. And Wilfried, in the closing yesterday, made the argument for the need for multidisciplinary research, and that's really what we were doing here. We wanted to make it possible for people coming from all aspects of not just engineering, but also social science, even healthcare, to be able to use this hardware system as a tool to advance their research. But very importantly, we didn't want to just give them the hardware. We wanted to give them the software, so that otherwise everybody else their first step would be to build their own software. So that's where ROS came in. So ROS, or the Robot Operating System, is an open source toolkit for developing robot applications. We release it under a permissive open source license. And so if you're not familiar with open source, what that means is that I'm posting it on the internet, I'm making it available for all of you to do just everything that you want to do with it. There's no constraint. You can contribute back to it if you like, but you don't have to. You can take it, you can change it, you can embed it in your product. You don't even have to tell me that you're using it, which also means that we're in the difficult situation, if you're in this business, of not knowing all of your users or customers, because they're not all going to self-report. Enough of them do that you figure out some of the more interesting use cases, which I'll talk about. But that's kind of the premise, is we put this out there, and on the hypothesis that people will find it useful and they'll do good things with it, and also enough of them will contribute back that we get this flywheel effect. So we shipped out those robots to about a dozen of the best research labs in the world, and we made on the condition that they would in turn contribute some of what they were doing back to this open source community. This is kind of how we started to establish critical mass. And I'll also mention, and I'm telling these stories because I think these are relevant as we think about how to engage in the next generation of innovation. I think it's a good success story. We also had an intern program, which was very, very important. We brought in some of the grad students from the leading labs in the world. They would come in, they would work with us. Importantly, if they came to work for us instead of going to work for, say, Google or Apple, when they went back to their home labs, they could take their work back with them, because they came and they did all this work in the open, which meant that they could take that work back to their lab. It meant they they took the tools back as well. So they started getting their home lab to use ROS to run their robots. And we thought about them as like contagion vectors. They would come and get infected with this when they worked with us at Willow. They'd go back and infect their colleagues. And some of the people here these people are now spread all around the robotics industry throughout the world doing some pretty damn important things. Like the guy on the far right over there, that's Ian Goodfellow, who went on to invent generative adversarial networks. So, just as one example. So we're here to talk about embodiment. Let's look at a few embodiments. And there are literally hundreds of companies around the world now, and also many hundreds of research labs that build their work on top of this open platform. And I can only have time to give you just a few examples, but I want to show you kind of the breadth of applications that you can see if you decide to take this approach of putting open tools out in the world. I'll focus mainly on commercial applications here. So this is a company called Dexery. They've got this 14-meter tall, very heavy robot. This is a warehouse, and what they're doing is inventory scanning. So this is a mobile system that roams around a warehouse and helps basically the facility manager keep track of what's where in the warehouse. You might have seen these systems operate in supermarkets at a much smaller scale. This is the same thing, but kind of blown up to a warehouse scale. Also in the warehouse or factory space, this is from a company called Collaborative Robotics. This is Brad Porter, who was previously a VP of robotics at Amazon. This is his latest company, and they've just released this system, which now we've got that mobile component from the Dexery system, but it's got a manipulation piece as well. So it's got these arms that allow it to grab carts and start to move things around in the world. Also running ROS. This one is one of my favorites, and this solves a problem that I had no idea existed. It turns out if you have a commercial airplane, you periodically have to repaint it. And so every once in a while, you bring the plane in and you put an extra coat of paint on. After you've done that a few times, the accumulated weight of the paint becomes a problem because now you're burning more fuel to fly a heavier plane around because you've made it bigger and heavier. And so you have to strip that paint off. And it turns out stripping the paint off an airplane is an ergonomic disaster for the people who do it, as well as they tend to do it with either noxious chemicals or kind of a sandblasting approach. So this is a company that has built a robot to do the paint stripping, and it uses this amazing 20-kilowatt laser that they actually pipe through the arm of the robot. So it's a mobile system with an arm, and there's a version of this robot that's actually large enough to service an A380. So they can strip the paint, and they've even got a painting version as well, so you could strip it and repaint it. And again, they use all the same software. We can go into the outdoor world and look at agriculture. Layla showed yesterday a small robot as a kind of at the smaller form factor for what people are doing with agriculture. This is a company that's going after a different problem. They're making these very big systems, but they're making them multi-purpose. And their goal here is to limit the amount of soil compaction that you have. Because apparently, I'm not an expert in this, one of the problems you have in agriculture is you drive these machines over the field many times. And you drive many different machines over the field. You end up compacting like 60 to 80% of the soil, which actually damages the soil. So the argument from this company is that what they're able to do, if you use this one machine and drive it very carefully, then you can only touch 5% of the soil in a field. I'm not making the argument for any of these particular applications, but I just want to emphasize the diversity. We can also bring it inside. LG has just released this, I think it's called the Q9, and it's an AI companion device. So this is a mobile robot for your home that is meant to do, I'm not quite sure what. It's meant to be a platform that you can do whatever you want with it, and I don't think, unlike Door, who has made a companion system that has a very specific purpose, I think this one hasn't found its purpose yet, but everybody is trying to make mobile robots for the home, and this is the latest example. Now, rather than argue for the utility of any of those particular applications, I just want to say that it's really an open platform that enables this kind of diversity. It's the existence of this open platform that lets all those people do all those experiments. I'll jump forward on time here. I just want to also share that how do we bring more people into this field? We do a developers conference for the ROS community called ROSCon. We do it every year. In 2018, we actually did it here in Madrid at the NH Euro building, just a few miles, a little bit north of here by the Real Madrid Stadium. And by far the most compelling presentation came from this high school team from North Carolina called the Zebracorns. They compete in a robotics competition called FIRST, and they took this software that we had developed for, graduate students and professionals, and they had managed to apply it as high school students in this competition that they were engaged in. And their presentation absolutely brought the house down at the conference. It was so gratifying to see that we were able to bring these young kids into the robotics field and using tools that were really designed for professionals. And at that moment, I was just like, I'm so happy I don't have to compete with these kids to get into college or grad school, because I would have absolutely no chance. I will then just say that basically, what can you do about this? As an academic or an industrialist, you can choose to adopt these systems, and you can choose to contribute back to them. You have the power to do that, and I would encourage you to do that. If you're in a position to direct funding, whether that's in government or philanthropy, you can encourage the development of openness. If you're running a program, if you're funding something, you can say, well, if I'm paying for it, I'd like you to share the results in some fashion. Not just publish, but actually share the code, share the data, make it available in a way that is going to contribute back to this commons that we're all building upon. And then everyone is just welcome to participate. These communities, I'm arguing for the importance of the ROS community, but there are other open communities that everybody is welcome to participate in, to engage, to discuss. And we do a conference every year. We just did this was ROSCON last month, or month before last, in Odense, Denmark, just outside of Copenhagen. We had 1,000 people come together to talk about robot software, which is kind of a niche topic, but it turns out if you build the community in the right way, you can get 1,000 people to come together and talk about it. We do this every year, and I was talking with Tan about this yesterday. We'll be in Singapore in October 25. So I'll just leave it there. Thank you.